Welcome back to the Deep Dive. Today we're tackling a topic that honestly used to be the most reliable cure for insomnia in enterprise tech.
That's putting it lightly.
Right. But now it's become one of the most dynamic, high-stakes battlegrounds out there. And user computing. Specifically, we're diving into this massive architectural shift that really hit the EUC market in 2025.
And it wasn't a gentle evolution. Our sources are all describing it as a definitive fracture, a real break.
And it's driven by, what, economics, physics, and strategy all at once.
It's a complete paradigm shift. And you're right, it used to be a very, very sleepy corner of IT. I mean, for 2 decades, the default, the guaranteed secure solution for remote work was virtual desktop infrastructure, VDI.
But VDI always came with this incredibly complex, costly, and capital-intensive downside.
Absolutely. Organizations were basically stuck. It was a binary choice. You either deploy this hugely complex, expensive on-premises VDI stack.
One managed by what the industry affectionately called a legion of specialized engineers.
That's the one. Or you risk everything with an insecure VPN connection to a completely unmanaged endpoint. Those were your only 2 real options.
And when our sources talk about that VDI stack, they mean the sheer administrative burden of that DIY era. This wasn't just, managing a few servers.
Not at all.
It required dedicated specialists just to manage the connection brokers, the load balancers, the SQL databases for logging, the licensing servers. It was just a massive CapEx drain.
A perpetual source of operational overhead and a highly specialized skill set. Most mid-sized businesses just couldn't afford to staff a team like that.
Exactly. The complexity was just staggering.
It was. But the reason we're calling 2025 the inflection point is that this monolithic idea, this one-size-fits-all interpretation that VDI was the only secure answer, it finally ended.
The market fractured.
It fractured. And it was largely due to 2 things. First, the cloud finally reached a level of maturity where it was a reliable utility. And second, the hyperscalers started commoditizing the underlying virtualization tech.
And that brings us right to the central conflict of this entire deep dive. The market has split into 2 fundamentally opposing philosophies, and it's all centered on one single question. Where should the actual compute happen?
That's it. Where should the application execute?
Right.
The old answer was always in a centralized, on-premises data center. But the new answers are split. First, you have what we're calling the cloud PC model. This is really the evolution of VDI.
Okay, let's unpack that evolution. So the cloud PC model, this is championed by players like Workspot and Microsoft's Azure Virtual Desktop, and it advocates for complete desktop abstraction into the public cloud.
Right. The desktop is delivered as a utility. It shifts that huge upfront capital expense, the CapEx, to a predictable operational expense, or OpEx.
Okay.
The goal is to leverage the massive global footprints of Azure or GCP or AWS to stream the desktop image, making sure that desktop is, locally cached in the region closest to the user to minimize that pixel streaming latency. It's virtualization, but it's modernized and it's outsourced.
But then you have the radical challenger, the philosophical opposite.
The Secure Enclave model.
Exactly, exemplified by a company like Venn. And this is where the narrative gets really interesting because it's an anti-VDI philosophy.
It is a radical rejection of VDI's core premise. The Secure Enclave model says that the powerful device you already own, your modern, high-end MacBook or Windows laptop, is perfectly capable of running applications locally.
So the key isn't to centralize the desktop.
No. The key is to establish an ironclad, encrypted, and logically isolated security perimeter, the Secure Enclave, right on the endpoint itself. And this model directly attacks VDI's 2 biggest historical weaknesses, cost and latency.
That is a true strategic divergence. We're not just debating how to manage VDI anymore. We're debating whether VDI is even necessary.
Precisely.
So what specific forces drove this monumental split in 2025? Our sources point to 3 major forces, 3 tectonic pillars that are shaping every procurement and architectural decision right now.
And we really need to understand these pillars to grasp the market dynamics. They are: first, that aggressive pivot to SaaS control planes, getting rid of that operational DIY nightmare. Second, the intensified war over display protocols, which is all driven by user intolerance for latency.
And
third, the highly controversial licensing reckoning that followed the Broadcom acquisition of VMware, which, it threw the entire established order into chaos.
Let's dive into those pillars now, starting with that shift from self-managed infrastructure to a turnkey utility.
Let's do it.
So as we established, the original VDI architecture was a true DIY era.
Hmm.
You needed that legion of specialized engineers just to maintain the connection brokers, load balancers, database servers, and, critically, the licensing servers.
And that operational overhead was a constant drain on budget and manpower.
But that era is not just waning.
It's being aggressively dismantled by customer demand. The market pivot is all towards SaaS-based control planes because customers are no longer interested in budgeting for infrastructure components. They're just not.
They are budgeting for outcomes.
Exactly. The outcome is simple. I need 500 available secure desktops tomorrow morning. That's it.
So all that complexity moves from the customer's balance sheet and their operational team over to the vendor's cloud service.
Right. And this is where we see a crucial differentiation even within the public cloud model. The whole SaaS versus PaaS spectrum.
Okay, let's use an analogy here to make this really clear for everyone.
That's a great idea because AVD and Workspot sit on opposite sides of this. If you think about moving a workload to the cloud, PaaS, platform as a service, like Microsoft AVD, is like buying a high-performance engine, a chassis, and some really sophisticated building plans.
Okay, so they give you the core parts.
Right. They give you the foundational components, the platform, but you, the customer, you have to assemble the cooling system, tune the fuel mixture, manage the tire rotation, and handle all the maintenance yourself. You still need those specialized mechanics, your VDI engineers, to manage it.
And what about the SaaS model in this analogy?
SaaS, software as a service, like Workspot, is like leasing a fully assembled, guaranteed vehicle. You pay one predictable monthly fee, you get in, and you drive.
And if it breaks down?
If it breaks down, the vendor is liable. They fix the entire thing, usually automatically. The risk and the complexity of the underlying assembly is entirely on the vendor.
And Workspot has positioned itself aggressively at that turnkey SaaS end of the spectrum.
Exactly. They offer a strictly turnkey service. That means the vendor Workspot assumes not just the management burden, but the actual liability for the desktop's availability, and they back it with that extreme 99.99% SLA.
So their whole value proposition is that IT just defines the requirements.
And Workspot handles the provisioning, the orchestration, the continuous monitoring everything needed to meet that guaranteed outcome.
On the other hand, Microsoft AVD, while it's immensely popular and powerful, it clearly operates on that PaaS model.
Precisely. Microsoft manages the foundational shared components, the broker, the web access gateway, the license entitlement. That's the platform they provide. But AVD leaves the three major headaches of virtualization, image management, scaling logic, and profile management entirely up to the customer.
That's the assembly required part of the analogy.
It is. You still need that specialized IT maturity to manage the golden images, to tune the complex auto-scaling scripts that control cost, and to properly configure FS logics for user profiles. It saves you the cost of the hardware, sure, but it doesn't save you the cost of the high-end VDI engineer you need to manage the complexity that Microsoft hands over.
Okay, so that's the operational hinge. The second pillar driving this shift is all about user experience, and specifically the unyielding enemy, latency.
Right. Remote work is permanent now, and the tolerance for input lag it's evaporated, especially for workstation class users.
We're talking about the CAD designers, the high-frequency financial traders, the video editor.
Exactly. If you can't get workstation performance over the network, VDI simply fails. The whole project is a non-starter.
So the battleground here is the display protocol, this specialized language used to transmit pixels and inputs across the world.
And the goal is to transmit the maximum quality with the minimum bandwidth and the highest possible tolerance for latency. We've got 4 major contenders, each one optimized for different conditions, reflecting different trade-offs.
Let's start with the one that's been the gold standard for a long time. Citrix HDX and its proprietary tech. It's still the best for truly challenging network conditions.
It is. And the secret sauce is their proprietary reliable UDP protocol called Enlightened Data Transport, or EDT.
So what's the difference? Why is that better than standard TCP?
Well, TCP, the standard internet protocol, really struggles when latency gets high. It has to wait for acknowledgments, and that slows everything down. EDT is engineered specifically to function on highly degraded or inconsistent links.
So we're talking about things like satellite connections or maybe someone working from a high-speed train on a shaky 4G link?
Exactly that. It can operate on as little as 150 kilobits per second for basic office work. That is an astonishingly low bandwidth requirement.
And what about latency tolerance?
It's excellent. It stays responsive even with 300 milliseconds of round-trip delay. That 150 kbps isn't just a number. It means your application is actually usable even when your network quality is terrible. You're not just stuck staring at a frozen screen.
Okay, so that's Citrix. Now, Omnis's Blast Extreme, coming out of that VMware heritage, is the other formidable legacy competitor.
Mhm.
How has that protocol matured to challenge Citrix?
Blast Extreme has matured a lot, mostly by leveraging modern compression codecs. Specifically, we're talking H.265 or HEVC and the even newer AV1 codec.
And the technical implication of that is pretty huge, right?
It's huge. H.265 can offer up to 50% better compression efficiency than the older H.264 standard. This is crucial for delivering high-fidelity, high-resolution visuals like 4K graphics, but with significantly less bandwidth. For a financial user, for example, they can see crisp charts without compression artifacts, even during rapid screen updates.
But that high-fidelity encoding, it comes with a cost on the server side, doesn't it?
It often does. To get that smooth, low-latency compression, Blast Extreme usually requires dedicated NVIDIA GPUs for hardware encoding on the host side. That adds significant hardware cost and complexity to the whole VDI cluster.
I see.
And like Citrix, Blast defaults to UDP with a very sophisticated network intelligence layer that dynamically adjusts frame rate and bitrate in real time. It can seamlessly fall back to TCP if the network is highly restrictive. It's a very strong protocol, tolerating latency up to about 250 meters.
Okay, moving to the hyperscalers. RDP is usually associated with that classic, slow, laggy remote session. So how have Workspot and AVD optimized RDP to be competitive?
Well, they aren't really trying to build a better protocol than EDT or Blast. They're trying to eliminate the distance. Their RDP backbone relies heavily on integration with the massive Azure global network.
So the optimization is geographical.
It's all geographical. By ensuring the desktop is provisioned in the Azure region nearest to the user, they reduce that crucial last-mile latency that traditionally plagued RDP. Their performance is less about protocol resilience and more about network proximity and stability.
And finally, we saw the rise of a more specialized browser-first approach, which is championed by Nutanix Frame.
Frame is a very clever architectural solution. It uses the Frame Remoting Protocol, or FRP, which is built on WebRTC and modern web standards.
And because it relies on the browser, it eliminates the need for any client-side software installation.
Exactly. A user can just open Chrome, log in, and be presented with a high-fidelity 4K 60 frames per second desktop. This is ideal for use cases like large university labs or for rapidly onboarding temporary contractors where IT just can't mandate software installation.
But it's not a low bandwidth solution.
No, it's optimized for quality and ease of access. Its bandwidth requirement, around 1.5 millips minimum, is significantly higher than Citrix's benchmark for basic task workers.
Okay. If complexity and the physics of latency weren't enough, our third pillar is purely economic and extremely disruptive. The acquisition of VMware by Broadcom and the subsequent spin-off of the EUC division into Omnissa, that triggered what we're calling the licensing reckoning.
And this wasn't just a rebrand. It created a massive system-wide market friction. The core issue is the new decoupling of the Horizon VDI entitlement from the underlying vSphere infrastructure licensing. It used to be this convenient bundle, now it's separate, forcing customers into what looks and smells like a compliance trap.
Tell us about that trap, specifically this new SESCU VVF for VDI.
Right, so organizations using Omnissa now have to license their ES-DXi hypervisor hosts via Broadcom's new VMware vSphere Foundation for VDI, or VVF for VDI. The controversy isn't just about the shift to subscription pricing, it's about the strict restriction imposed on that license.
And what's the restriction?
Hosts licensed with the VVF or VDI SKU are strictly forbidden from running any non-VDI workloads.
Wait, I need to pause here because this is one of the most punitive points in our sources. If an organization has a dedicated VDI cluster, they often run essential supporting services like domain controllers, SQL servers, license servers as VMs on that same cluster. Are you saying they can't do that anymore?
That is precisely what the restriction mandates. If an administrator places a domain controller or a SQL server, which their VDI environment depends on, onto that VVF licensed cluster, they are in violation of the licensing agreement.
So this forces organizations, especially smaller ones, to maintain physical separation of resources.
It does. They must buy separate hardware, separate licenses, and maintain entirely distinct VDI clusters and server clusters.
That seems almost designed to trigger customer flight. I mean, if you were a small branch office that previously leveraged one converged cluster for both servers and desktops, this mandate instantly destroys your ROI. It adds immediate hardware and management complexity.
It absolutely pushes customers toward alternatives. It destroys the original ROI argument for converged infrastructure in DDI. You have to wonder if it's a strategic move by Broadcom to shed smaller, high-maintenance customers, focusing only on the largest enterprises that already maintain that physical separation.
Well, on this is dealing with this fallout. How has Citrix been navigating the chaos?
Citrix has retreated into what we'd call a strategic retrenchment. They are doubling down on being a high-value hybrid niche. They've maintained their premium price point, focusing on the quality and resilience of HDX.
And they streamline their offerings.
They did, into universal hybrid multi-cloud subscriptions with defined tiered licensing, running up to $23 a user for their Premium Plus offering. Their message is clear. We are the best, and we charge accordingly.
But by maintaining that high-cost structure, are they also inadvertently pushing mid-market customers away?
Unquestionably, that premium cost, combined with the administrative shock from Broadcom's licensing, is forcing mid-market customers who still need VDI but can't justify over $20 a user to actively seek simpler, more cost-effective alternatives like Parallels RAS, which we'll get into later.
So the complexity and cost of the Titans are now just an unbearable barrier for many organizations.
It really is.
Let's pivot to Workspot, a key player that has skillfully leveraged these pillars of complexity and cost to define a new model. They call it the Global Desktop Fabric, and it's about fundamentally simplifying cloud PC delivery.
Right. Workspot aims to be a true cloud PC utility, and to do that, it's eliminating the traditional siloed architecture. Think back to the old VDI world. If you needed desktops in London, New York, and Singapore, you didn't just stand up 3 sets of servers.
You build 3 separate VDI silos.
Exactly, each requiring its own dedicated management stack, its own brokers, its own gateways. It was a nightmare.
So the Global Desktop Fabric centralizes all of that management.
It does. The administrator uses a single console, a unified control plane, to define a desktop pool. And the Fabric instantly orchestrates the deployment across whichever public clouds they choose, Azure, GCP, or AWS.
So it abstracts away the highly complex proprietary APIs of the different public clouds, like Azure Resource Manager versus GCP's Compute Engine APIs.
Precisely. It's offering true multi-cloud agility from a single pane of glass, which is revolutionary for global IT teams.
This unified management leads us to their pivotal architectural decision, especially for security and trust: the separation of the control plane from the data plane.
This is a critical point for security-conscious enterprises, especially those in regulated industries. Let's use an analogy to make this clear. Think of the control plane as the highly secured map room.
Okay, the map room.
It holds the policies, the authentication logic, and the navigation instructions for the desktop delivery. The data plane, on the other hand, is the secure shipment container itself. It holds the actual virtual machines, the corporate data, the user profiles.
So how does Workspot use this separation?
The control plane, the map room, lives securely in Workspot's cloud. But the data plane, the secure container, resides entirely within the customer's cloud subscription.
So Workspot manages the orchestration and routing without ever having the decryption keys or physical access to the customer's data.
Exactly. They manage the desktop, but they never possess your data. This is essential for maintaining data sovereignty and satisfying regulatory requirements that mandate customer control over that data layer.
And Workspot has staked its reputation on what they claim is the industry's first cloud PC with a 99.99% SLA on availability. This isn't just a marketing metric, right? This is a commitment that fundamentally shifts the vendor's liability.
It's a critical distinction, and we need to understand the nuance here. In legacy VDI, and even with most hyperscaler pay offerings like AVD, the standard SLA covers infrastructure availability.
Meaning, is the virtual machine powered on?
That's it. If the VM is running, even if a licensing server error or a misconfiguration in the broker stops the user from logging in, the provider has met its SLA. The user is still dead in the water, unable to work, but the infrastructure is technically up.
So Workspot's SLA covers the user's ability to successfully connect to a functional desktop and actually start working.
Yeah.
They're responsible for the entire chain of connectivity.
Exactly. They take responsibility for the whole chain, from the client endpoint through the gateway to the operational desktop. And to back that aggressive promise, they use what they market as the never-fail grid.
The Cloud PC Utility Grid.
Right, and this is active multi-cloud redundancy built into the fabric. If Azure US East suffers a catastrophic regional failure, the global desktop fabric automatically and instantly reroutes users to standby desktops provisioned in GCP or a different Azure region, or even an on-premises cluster.
Thus, catastrophic disaster recovery is no longer a manual process initiated by a specialized engineer. It becomes an automated routing decision handled by the platform itself. That's a powerful argument for global operations.
It's huge. And let's talk about the operational side. VDI administration is historically plagued by operational blindness. A user complains, "My desktop is slow," and IT spends 2 hours just guessing. Is it their home Wi-Fi? The cloud gateway? The VM's CPU?
And Workspot Watch attempts to eliminate that blindness.
It does through high-resolution integrated observability. It's a telemetry platform that continuously pulls millions of data points every 30 seconds. That's the high-resolution granularity.
Whereas legacy tools might pull every 5 or 15 minutes.
Exactly, which means they miss those critical micro-outages that cause user frustration. The 30-second granularity allows IT to correlate momentary issues. They can see a sudden latency spike and correlate it with a specific internal event, like a Windows update process kicking off, or an external one, like a regional ISP brownout detected at the user's client side.
So it's proactive.
It's proactive. The vendor is watching and correlating system health for you, turning user complaints into actionable data points.
Now for the economics. The biggest financial fear for any VDI migration to the public cloud is cloud bill shock. That complexity of consumption billing for compute, storage, IOPS, egress bandwidth.
Workspot's flat rate predictability is their direct counter to this. They bundle all the cloud infrastructure costs into a single, predictable, per user per month flat fee. For a knowledge worker desktop, this might start around $75 a month.
And that's incredibly attractive because it acts as an insurance policy against utilization variance. IT gets budget predictability.
It does. But to offer that flat rate and guarantee the SLA, Workspot has to be incredibly efficient on the back end. And this is where their incentive structure becomes fascinating.
How so?
Well, Workspot uses an integrated FinOps engine to manage the power states of the underlying VMs. It shuts them down instantly when users disconnect and spins them up just in time for login. The key insight here is the incentive alignment. Workspot takes on the financial risk of utilization.
So if a user accidentally leaves their VM running 24/7, Workspot eats that compute cost.
They eat the cost. This incentivizes them to be maximally efficient. Whereas if you're operating on a native consumption model like AVD or AWS hourly billing, the hyperscaler profits directly from the customer's inefficiency. They benefit from those zombie VMs that cause bill shock.
It flips the financial risk structure.
Completely. It makes Workspot's flat rate not just about simplicity, but about strategic risk transfer. And one last point. While Microsoft AVD is inherently bound to Azure, Workspot's multi-cloud agility gives organizations the freedom of choice to use the cloud provider they prefer, all managed from that single abstracting console.
Okay, we spent a lot of time analyzing the new generation of cloud VDI, which is all about optimized pixel streaming. Now we come to the complete paradigm shift, the anti-VDI approach championed by Venn. This solution doesn't try to optimize latency.
It eliminates the problem entirely. Venn is a true disruptor because it forces us to re-examine the core assumption of VDI, that centralization equals security. It just rejects that premise. It flips the model.
So instead of accepting the physical limitations of the speed of light by moving compute far away to the data center,
it brings the security perimeter directly to the compute on the endpoint device.
so how does the secure enclave architecture actually manifest on the device itself? What's the user experience like?
Venn creates a secure enclave, which is a highly secured, virtualized, encrypted container right on the user's physical laptop Windows or Mac. The applications run natively on the local CPU and GPU.
And because the application traffic doesn't traverse the wide area network,
You eliminate input latency. This is transformative for high-performance users, the video editors, the financial traders, the software developers, who need zero latency to perform their work. They're getting their full local hardware performance without any of the VDI drag.
if the compute is local, the security has to be absolute. The key visual mechanism for enforcing that security is the blue border.
The blue border is the crucial logical isolation mechanism. Any corporate application running inside the enclave, say, a sensitive ERP system or a company-owned Word document, is visually surrounded by a strict blue border. This boundary is enforced by kernel-level drivers.
And it prevents data leakage.
Strictly. The clipboard, the file system, the network traffic within the border are all logically isolated from anything outside it. The most common example is simple copy-paste. You simply cannot copy text from a blue border Word document and paste it into a personal Gmail window running outside the enclave.
What about screen capture?
The enclave intercepts OS calls for screen capture. If a user tries to share their screen via a personal Zoom or take a screenshot, the blue border windows just appear as black boxes. It neutralizes unauthorized intellectual property leakage. This is security embedded at the kernel level, not just a policy overlay.
One of the biggest obstacles that prevents organizations from securing the entire distributed workforce is the BYOD problem. Bring your own device. Employees reject full mobile device management.
Because they don't want IT taking control of their personal laptop and wiping their photos or personal apps.
Right.
The Secure Enclave model brilliantly addresses this privacy versus security conflict with granular control. Venn allows IT to send a highly specific remote wipe command that only destroys the Secure Enclave itself.
So it deletes the corporate encryption keys, renders all corporate data unreadable, and deletes the work apps.
All without touching the user's personal OS, family photos, or unrelated personal apps. It's a huge win for privacy and compliance, especially under regulations like GDPR or CCPA. The user accepts the security tool because it respects their privacy boundary.
And VDI's greatest weakness is that it's useless without a strong internet connection. Since Venn runs locally, it had to solve the problem of secure offline work.
And it does that via the lease mechanism, the so-called time bomb policy. Administrators set an offline lease, maybe 10 hours, maybe 48 hours, depending on the role. A road warrior can work securely on sensitive data while traveling without internet.
But if they fail to check in before the lease expires,
The enclave instantly locks down. The keys are suspended until reauthentication occurs. This ensures that a lost or stolen laptop, even one containing highly sensitive corporate data, eventually becomes useless from an access standpoint. It's vital security control.
finally, regulators like FENIARA require an immutable audit trail. How does the enclave provide this without being overly intrusive?
Because the enclave is a managed boundary, it provides granular logging of almost every action taken within that blue perimeter. Every file access, every application launch, every copy-paste attempt.
So it satisfies those rigorous audit log requirements.
It does. And crucially, because of the isolation, IT gets a perfect audit trail of work activity without having to infringe on the user's personal browsing history or activities outside the blue border. Security is achieved without surveillance.
The economics of Win are perhaps the most compelling factor here. If you eliminate the need for server-side streaming and all the associated cloud infrastructure, you're dramatically slashing the total cost of ownership.
Venn inherently represents the lowest hard dollar TCO in the entire EUC market. Why? Because it eliminates the massive Azure and AWS compute and storage bills entirely. There's no elastic cloud compute instance to pay for, no IOPS cost, zero bandwidth egress fees related to the VDI session. The server side goes to zero.
So the cost is reduced purely to the software subscription, leveraging the device the employee already owns.
Exactly. The source material suggests a typical subscription cost is between $15 to $25 per user per month. When you combine this purely software cost with the fact that it leverages the BYOD device, you remove the need for the organization to buy or lease thin clients or cloud PCs. This factor alone drives estimated TCO savings of 40 to 60% compared to traditional cloud BDI. It's an economy of elimination.
The forces of disruption and the rise of the secure enclave are undeniable, but the massive scale of the hyperscalers still dictates the direction of the cloud market. So we have to turn our attention back to the massive players driving the cloud PC model, Microsoft and AWS. We'll start with the 800-pound gorilla, Microsoft Azure Virtual Desktop, or AVD.
AVD fundamentally altered the VDI economic equation, and it was largely due to a single proprietary technical innovation, Windows 10.11 Enterprise Multi-Session.
Before AVD, VDI was always 1.1. One full Windows license, one VM, one user, and that was prohibitively expensive for most organizations. How did multi-session change the game?
It allowed multiple users, our sources suggest up to 10 or even 20, depending on the workload, to share a single Windows client OS VM. This density drastically reduces the compute cost per user.
So instead of paying for 20 separate server licenses and 20 compute instances,
You pay for one instance shared by 20 people. And crucially, this multi-session OS SU is exclusive to Azure. It acts as a massive gravity well, pulling VDI workloads away from AWS, GCP, and on-prem, where only 1.1 client VDI is possible.
the economics are compelling, but as we established, AVD is PaaS, not a finished product. That cost saving comes with a significant management burden.
That burden is substantial. And it's where many organizations underestimate the TCO. The customer is entirely responsible for three key areas. First, image management patching, updating, and version controlling the golden images that all users connect to.
And second, scaling logic.
Right. Writing complex scripts and configuring intricate rules to turn those shared VMs on and off at optimal times to save money. And that scaling logic is critical for avoiding bill shock.
What does that complexity actually involve?
It involves constant tuning. For example, you can't just turn a VM off when the last user disconnects. You need a system to recognize when the last user is leaving, put the VM into a session drain mode to prevent new logins, wait 15 minutes, and then gracefully shut it down.
And if you tune it wrong?
If you tune it too aggressively, users experience slow logins. If you tune it too loosely, you pay for zombie VMs. This often requires managing sophisticated time-of-day automation, calculating peak load, and writing custom PowerShell scripts.
And the third major burden is profile management, which requires expertise in something called FS logics. Before we move on, what is FS logics and why is managing it correctly so essential? Is it basically containerizing the user's desktop personality?
That's a great way to put it. FS logics effectively places the user's profile, their documents, their registry settings, their shortcuts, their desktop personality into a secure, portable container.
Which is mandatory in a multi-session, non-persistent environment.
It is. Otherwise, the user would lose all their settings every single time they logged in. But setting up, maintaining, and troubleshooting that shared profile environment is non-trivial. It requires significant specialized knowledge.
So native AVD lacks the GUI and automation for these complex tasks, which is why we see the rise of tools like Nerdio.
Exactly. Tools like Nerdio exist purely to provide the necessary automation and a simplified graphical interface to make the pay-as model of AVD manageable for mainstream enterprise IT. Without them, AVD management can be labor-intensive and highly prone to error, particularly around that complex scaling logic that determines the size of your variable cloud bill.
Okay, if AVD is the complex, flexible engine and chassis approach, Windows 365 is the opposite. It's Microsoft's true sauce move, offering simplicity and predictability.
Windows 365 removes the complexity by providing a dedicated persistent 1.1 VM for every user. It abandons multi-session complexity and scaling logic entirely. The philosophy is to make the remote desktop feel exactly like a physical, dedicated PC, but streamed from the cloud.
And the management integration reflects that focus on simplicity.
It does. Cloud PCs are managed through Microsoft Endpoint Manager, or Intune. They're treated just like physical hardware. This removes the need for specialized VDI certification for IT staff. They use the same tools and policies they already apply to physical laptops and phones. It dramatically lowers the bar.
But the cost trade-off for that simplicity is significant.
It is. W365 charges a fixed monthly fee per user, regardless of utilization. While this provides highly predictable budgets and removes the risk of bill shock, it introduces what our sources call the always-on tax.
You pay for that cloud PC 247.
247. This makes Windows 365 a much higher TCO solution for sporadic users, those who work less than about 80 hours a month. Because you're paying for 600 hours of idle compute time they're not even using. It's a premium for simplicity.
Okay, let's shift to AWS. AWS Workspaces was an early pioneer in the desktop-as-a-service market, and their offerings have evolved. The first key strategic differentiator they hold over Microsoft is OS agnosticism.
That's right. They're not exclusively focused on Windows. AWS supports Amazon Linux desktops alongside Windows, which is critical for organizations with strong engineering and developer workflows.
So they can avoid Windows licensing costs for those users.
Which positively impacts the TCO for those specific, often high-cost users. AWS also had to keep pace in the protocol wars, shifting from the legacy Pico IP protocol.
Right, Pico IP was licensed from Teradici, and it struggled with high latency and modern multimedia.
It did. The shift to the new Workspaces Streaming Protocol, or WSP, was mandatory. WSP is cloud-native, more resilient, and crucially supports modern features essential for today's collaboration, specifically two-way audio-video redirection.
Why is that so important? For things like Zoom and Teams calls?
Exactly. You need the media streams to bypass the virtual desktop entirely, connecting your local mic and camera directly to the cloud conferencing platform. Without this optimization, the traffic has to go to the VDI, then to Zoom, then back to the VDI.
And you get that noticeable 200, 300 meters desynchronization, the tromboning effect.
Right. WSP addresses this to ensure high-quality UC experiences. And finally, AWS made a recent strategic pivot with Workspace's Core. What's the business implication there?
Workspace's core is AWS's recognition of hypervisor neutrality. It's an API layer. It strips away the AWS native client and management layer and exposes VDI infrastructure APIs directly to major partners like Citrix or Omnissa.
So it's a bring-your-own-broker model.
It is. Customers can use the VDI broker they already know, say the Citrix Studio console to provision and manage desktops that are actually running on AWS infrastructure. This reduces costs by about 20% by stripping out the native AWS management layer, making AWS a much more attractive infrastructure target for legacy VDI customers who are wary of that Azure gravity well.
It's time to revisit the legacy titans, Omnissa and Citrix. They're fighting hard to maintain relevance, especially after the Broadcom-Nissa split, which alienated a huge portion of their base.
The immediate pain point, of course, is that licensing complexity. Horizon customers are stuck with the VVF for VDI restriction, forcing that physical separation of VDI and server clusters.
And Omnissa has transitioned to a subscription model that requires continuous aggressive validation enforced through SaaS technology. They introduced the Omnissa License Module, or OLM,
which requires the Horizon console to communicate with the Omnissa Cloud Control Plane every 24 hours.
Correct. And if that sync fails, say due to a prolonged data center network issue, the console enters a restricted mode. This prevents administrative changes and forces compliance. It's a powerful enforcement mechanism.
But technically, BlastExtreme has matured to remain a formidable competitor to Citrix HDX.
Absolutely. The technical depth is there. BlastExtreme now supports the most modern codecs, HEVC and AV1. HEVC provides up to 50% better compression than the old H.264 standard, which is essential for crisp 4K delivery.
And while that traditionally required expensive NVIDIA GPUs,
the latest Horizon release, 2506, introduced support for AMD hardware encoding. This is crucial because it gives organizations an alternative to the expensive single-vendor GPU stack, directly addressing that added hardware cost we discussed earlier.
And Omnissa is also exhibiting a strategic survival mechanism, hypervisor neutrality.
Their strategic pivot is expanding support for Nutanix AHV. Horizon 8 now officially supports it as a target hypervisor. This gives zSphere customers alienated by the VVF licensing a viable, managed path to migrate their underlying infrastructure to Nutanix while still keeping the familiar Horizon management layer. It's a life raft for a deeply disrupted customer base.
So let's talk Citrix. They're maintaining their premium price point by relying heavily on their technical moat, the HDX protocol, and Enlightened Data Transport, EDT. Is that technical gap truly wide enough to justify the highest TCO in the market?
For certain niche, mission-critical scenarios, the answer is yes. EDT remains peerless for those long-fat networks, connections with high bandwidth, but also high latency. Think intercontinental links between global offices or mobile workers on cruise ships or oil rigs.
And in those scenarios, EDT allows Citrix sessions to remain responsive.
Even with 200 or 300 milliseconds of latency, a threshold where TCP-based protocols often become sluggish and unusable. HDX is unique in its adaptive throughput, allowing basic task workers to function on as little as 150 kbps.
So given that Citrix and Omnissa often have the highest TCO, the VDI tax, plus the infrastructure tax, plus the management tax, what are the specific non-negotiable requirements that make that premium justifiable?
The cost is only justifiable where performance cannot, under any circumstances, fail, and where standard protocols break down. We're talking about 4K radiology imaging viewed over shaky hospital Wi-Fi, high-frequency trading floors where specialized peripheral redirection is needed, or highly regulated defense and aerospace environments. If your use case is basic knowledge work, this high TCO is likely not justified.
For those mid-market customers fleeing the complexity and cost of the Titans, Parallels RAS has positioned itself as the sane alternative.
Parallels RAS focuses entirely on simplification and stability. Unlike the complex architectures of Citrix, which might require 6 to 10 different server roles, storefront, delivery controller, and so on, Parallels consolidates these into a single, simple, high-availability pair. It drastically reduces the administrative footprint.
And they've paired this simplicity with a smart infrastructure exit strategy.
They have. Parallels has partnered strategically with Nutanix AHV. As Broadcom introduced the complexity of VVF licensing, moving the infrastructure from vSphere to Nutanix and layering the simplified Parallels RAS broker on top provides a stable, cost-effective exit strategy from the legacy ecosystem.
And finally, let's revisit Nutanix Frame, which capitalizes on simplicity via the browser.
Frame is the ultimate flexibility play. It's defined by its browser-first capability using the frame remoting protocol. It delivers 4K 60 FPS desktop sessions inside standard browsers like Chrome or Edge, requiring absolutely no client installation.
So a university computer lab where you don't want to manage 50 local PCs.
Exactly. You just have the students log in via a browser. This is invaluable for use cases where IT cannot mandate software, and it provides simple desks managed via a SaaS control plane, supporting workloads on AHV, AWS, Azure, and GCP.
We've covered everything from cloud utility models and licensing chaos to anti-VDI enclaves that challenge the physics of the data center. Now let's synthesize what this all means for you, for the listener's strategic planning around user experience and TCO.
The first, unavoidable truth we established is the core latency physics of VDI. Every single pixel streaming solution is bound by the speed of light. If the user is 50 milliseconds away from the data center, every interaction has a minimum 100 meters round-trip delay. You can optimize the protocol, but you can't escape that fundamental cursor lag.
The protocol matrix provides some memorable data points that illustrate the extremes of the trade-offs being made.
Right. If bandwidth is your primary non-negotiable constraint, you're working on a satellite link or a constrained public hotspot, Citrix HDX is the definitive winner, functioning down to about 150 kDPs.
But if latency tolerance is your constraint.
The Secure Enclave model, Venn, is the winner. It offers infinite latency tolerance and zero bandwidth usage during local execution because the application is running on the local bus. This also makes the offline mode not just a feature, but a structural necessity.
We mentioned unified communications, Zoom, and Teams earlier. This is the source of so many VDI user complaints. Why does VDI make video calls suffer from that painful 200-300 meters delay while local apps do not?
That's the classic you see hairpin effect or tromboning. If the application is running in the cloud VDI, your webcam data goes from your laptop to the VDI in the cloud, then to the Zoom server, then back to the VDI to be rendered, and then back to your local screen.
That double hop adds significant noticeable latency.
It does. In sharp contrast, the Secure Enclave model, because the application runs locally, allows the Zoom call to connect directly from the user's powerful laptop to the Zoom server. That's why Venn sessions experience 150 meters lower latency and native video quality. The local compute bypasses the physical network constraint.
So the TCO picture is no longer simple. It's a fundamental trade-off between guaranteed predictability, usage elasticity, and infrastructure elimination.
Guaranteed predictability is offered by the flat rate models Workspot and Windows 365. That flat rate acts as an essential insurance policy against cloud variants and unexpected consumption spikes. And it's often the cheaper solution for true power users, those logging 700 plus hours a month, because they mitigate the massive financial risk of high utilization.
And elasticity is the realm of AVD and AWS hourly billing.
This consumption model is the cheapest for task workers or shift workers, provided the organization has the IT maturity to build and maintain aggressive auto-scaling logic. However, this model is highly vulnerable to management error and those zombie VMs that forget to shut down, causing that infamous bill shock.
And the final piece, the lowest hard cost, clearly belongs to the Secure Enclave model.
Venn is the clear winner here because it eliminates the server and cloud compute costs entirely. The organization pays only a subscription fee, relying on the BYOD hardware the employee already owns. For organizations with thousands of contractors, driving the Azure or AWS compute bill to zero is a game-changing factor.
The ultimate takeaway from this whole 2025 market shift is that VDI is dead. Not the concept, but the idea of VDI for everyone is over. Success depends entirely on matching the architecture to the user persona.
Right. For the global enterprise, those demanding guaranteed turnkey reliability, managing thousands of users across continents, the recommendation is Workspot. Their global desktop fabric simplifies multi-region deployment, and that 99.99% SLA provides the operational guarantee and strategic risk transfer that large organizations need.
What about for the contractor, gig worker, or road warrior? Anyone who needs BYOD security and mobility.
That's Venn, hands down. VDI is too expensive and inherently latency-prone for these dynamic users. Venn provides zero latency performance, secures the corporate data on the devices they already own, and crucially, enables that necessary offline productivity that pixel streaming just cannot match.
And the regulated power user, the financial trader, the high-end engineer, or the specialized medical professional who needs high fidelity and specialized hardware redirection.
There you're looking at Citrix DAS or Omnissa Horizon. When 4K radiology images need to be viewed over shaky, high-latency Wi-Fi, or you need specialized peripheral mapping for a proprietary device, the superior technical resilience of the legacy HDX or BLAST protocols is still unrivaled. That is the only time the high TCO of the legacy titans is justified.
And for the large organization that is already deeply Microsoft-centric and cost-optimizing.
That would be Azure Virtual Desktop, but with the strong caveat that they must use a third-party management tool like Nerdio. If the organization already pays for Microsoft 365 E5, the AVD management license is often seen as free. And using Windows 10 multi-session provides the best price per head economics in the public cloud, as long as they have the IT maturity to manage the scaling.
Finally, for those caught on the fallout of the Broadcom acquisition, the VMware migrator seeking a simple, stable exit.
That's Parallels, RAS. As Broadcom introduced the complexity and cost of VVF licensing, moving the underlying infrastructure to Nutanix AHV and layering the simplified Parallels RAS broker on top provides a stable, cost-effective exit from the legacy ecosystem without migrating to a complex public cloud consumption model.
So when we synthesize the 2025 market, what we've seen is not just a market shift, but the definitive end of VDI for everyone.
We have. The market has permanently bifurcated into two specialized opposing strategies. On one side, you have cloud VDI like Workspot, AVD, and Citrix, which is essential for centralized, highly regulated streaming workloads where absolute data residency is paramount.
And on the other side?
On the other side, you have the rapid ascent of the Secure Enclave model driven by Venn, which targets the dynamic, distributed, cost-conscious BYOD workforce by eliminating network latency.
The key winners in this new war are the platforms that successfully abstract complexity. Whether that's Workspot abstracting the complexity of the multi-cloud infrastructure, or Venn abstracting the security requirements directly onto the device itself. The future desktop is certainly distributed and managed.
But the key structural debate is whether streaming pixels is necessary at all. We're no longer debating on-premises versus cloud, but latency versus centralization.
Which brings us to our provocative thought for you to chew on. If we accept that the fundamental challenge for VDI is the speed of light, a physical constant, and we observe the rapid acceleration of local compute power, particularly with powerful, cheaper chips like the Apple M series becoming standard, will the overwhelming cost and zero latency advantages of the Secure Enclave model eventually render pixel streaming virtualization obsolete for all but the most rigid, specialized data residency requirements? Is VDI fighting an unwinnable battle against the power of local hardware?